Hey guys, I'm Pat Kelly. Okay, in this problem, they give us a couple of snapshots of a geometric sequence, and then they ask us to find some specified term from that sequence. Okay, and what it really is going to come down to a lot of the times with geometric sequences is that one formula for a sub n always equals a sub 1 times r raised to the n minus 1. And we'll end up using that a bit, even in this one problem. Now, if I'm going to use that right off the bat, I would love to just plug and chug. If they want a sub 3, I'll put a 3 in right there for my n. I actually already even have a sub 1. They gave it to me. But I'm missing the r value. Okay? We're going to find it. In fact, if it helps, look at this equation as really having three key components, right? The a sub n, the a sub 1, and the r. And if they give us two of those pieces, we can always find the third. And that's what we're going to do, is we'll use the two pieces of information they did give us to find the r value for this formula, and then go back and actually use the formula for a sub 3, right? So let's get to it. The way I'll use this formula for the two pieces of information that they did give me is I'm going to view this a sub n as a sub 4. Let me go over here to do my work. A sub 4 equals, let's keep that a sub 1. It's still r because I don't know it, but n now is 4, right? So this r is going to be raised to the 3 power, okay? Let's plug in some more specifics. A sub 4, you know, because they told us, it's 27/4. So on the left side of this equation, 27/4 equals a sub 1, you know, again, because they told you, 16. And then r, I don't know, r sub 3. Okay? And now we'll solve for r, doing a little bit of algebra. I'll throw the 16 over the other side. I'll divide. So I'll get 27 over and 4 times 16. That looks like 64 equals r cubed. To solve for r, if you don't mind, I'll throw the r on the left side. Cube root both sides. It's always so nice when they do this. They give us perfect cubes in this case. Don't even have to waste the time to grab a calculator. Cube root of 27 is 3. Cube root of 64 is 4. So you've got your r value of 3/4. Right, we're in good shape. Let's come back up to this formula and fine-tune it a little bit. A sub n, we now know, will equal, I'll even fine-tune the a sub 1 I know is 16. And the r value you now know is 3/4. So 3/4. All raised to the n minus 1 power. And so this is a really nice formula to find any a sub n. Let's try to get the answer they want for this particular problem where they want a sub 3. So a sub 3 equals 16 times the 3/4, and my n is 3, so n minus 1 would be 2. So a sub 3 equals, let's square this, 9/16. 16ths will actually even divide out. It looks like an answer of 9. It's my third term for this sequence. Okay? Now I want to throw a tip your way because there was something fairly convenient for me in this problem, and I don't want you to get tripped up in a later problem and say, oh, he had an easy one. What I want to point out is in this formula, this 1 right here is the same as this 1 right here. And I say that to you because, let's play hypothetical here for a second. Let's say they had given me a sub 44 and also a sub 11. So you don't have a sub 1 in that case. What I'm trying to point out is, if they had given me a sub 11 right there, I'm going to put the a sub 11 right here, okay? And that subscript that I have circled there, that would be an 11. You're going to want to use the 11 right there as well, okay? That's going to help you with some of the later problems. You'll always be able to use this formula if they give you 2 pieces to find the third piece, even if they don't give you a sub 1. That's my worry here. I don't want you to be tripped up when you see something similar later, but they don't give you a sub 1. You can still work with it, okay? Hope that helps. You'll know if you get to some of your own problems, practice them, I know you'll do well, okay?